The diagram shows a circle, centre O, radius 10, as we can see on the diagram. The points A, B, C and D lie on the circumference of the circle such that AB is parallel to DC. The length of the minor arc AB is 14.8 centimetres. We can see that on the diagram. And the area of the minor sector ODC is 21.8 centimetres squared. Write down in radians the angle AOB. So AOB is this angle just here, which I'll just call it theta. Now we know if we're working in radians that L is equal to R theta, where L is the length of the arc. So 14.8 is equal to 10 theta. So theta would be 14.8 divided by 10 is 1.48 radians. Remember, you don't actually need a mark for radians. Find in radians the angle DOC. So DOC is this angle here, which I'll call phi for now. And we know that the area of the sector that I just marked, the sector ODC, is 21.8. And the area is a half r squared theta. And of course we know that the r is 10. So 21.8 is equal to half times 10 squared times phi. So that means that phi is going to be 21.8 divided by a half of 100. And so let's just calculate that and see what it gives us. So 21.8 divided by 50 gives me 109 over 250, or 0.436 might be the best way of doing that. 0.436 radians. Okay, so what do we want to do next? We want to find the perimeter of the shaded region. Okay, so that's made up of the two arc lengths, one of which we were given to start with. So that's 14.8 plus 14.8 plus the arc length here, which is going to be 10 times 0.436 using L equals R theta. Now, because this diagram is symmetric, these two lengths will be the same, and I'm going to call that length x. So I'm going to say plus 2x, and we'll go about finding that x in a moment. And let's just call the angle here alpha. Remember, because of the symmetry, they're both alpha, and this one is 10 as well. So I've marked it on the diagram, so I can say that alpha is going to be 2 pi, which is the angle all the way around a circle, take away these two, 1.48 and 0.436, and divided by 2, because just the 2 pi take away the theta and the phi would give us both of those angles, and we know they're equal, so we can divide by 2 to find one of them. So let's just calculate that. So 2 times pi take away 1.48, take away 0.436 and divide by 2 gives us 2.1845. 1.4, so well, I'll say 1 point like that. Okay, and then to find what we've called x here, we can use the cosine formula. So we know that's 10, and the angle in between, that's all good. So we can say x squared is going to be 10 squared plus 10 squared. Take away 2 times 10 times 10 times the cosine of 2.183, and so on. So need to make sure we're in radian mode. So it's not that one. So radians 4, okay. So we've got 10 squared plus 10 squared. Take away 2 times 10 times 10 times the cosine of my last answer. And we need to square root that. And that will give me 17.749. And so going back to the perimeter, we've got 14.8, add 4.36, add 2 lots of the 17.749. So the last answer, multiply that by 2, and then add on 14.8 and 4.36. That gives me 54.7. I'll just call it 54.7. And that would be in centimeters, and that's correct to 1 decimal place. So finally, we want to find the area of the shaded region. So let's go back to the diagram and figure out our strategy. So I'm going to do the area of that sector, the area of this sector that I was given, and then the 2 triangles. So let's do the area of the triangle first. So half AB sine C, so that's a half times 10 times 10. And then the sine of the angle, and the angle was this 2.183, which I believe was 2.184 when we rounded it. And so we can work that out. So 0.5 times 100 times the sine of 2.184. Which is 40.890. And so the area we want is going to be 2 of those, plus the sector that we were given in the first place, which I believe was 21.8. I'll go and check that in a second. So here we are, 21.8. And then the other sector has an angle of 1.48. So we can use a half r squared theta. And so we can calculate that. So we'll multiply that last answer by 2, and then add 21.8, and then add 0.5 times 10 squared, so that's 100, times the angle, which is 1.48. And 177.6 square centimeters.